Example 6.3 defines a function g, which has a domain of all real numbers, and the equation is given by g of x equals negative 2x plus 5. And that takes on the mx plus b format, so I can say that g is a linear function. And then I can also say that m is equal to negative 2 and 0, 5 is the y-intercept. So we can pull out the y-intercept, pull out the slope. Let's go ahead and graph. I'm going to graph the y-intercept first at 0, 5. And then your slope can be thought of as a ratio, negative 2 over 1. So that would require me to go down 2 and then to the right 1, and that gets me another point. And I can continue with this down to right 1 pattern as often as I like until I fill the window. And technically, if you have a straight edge in front of you, you only need 2 points to be able to draw a straight line if you have a straight edge. But since I'm doing this freehand, the more points that I have, presumably the easier it is for me to be able to draw a straight line. And this is what we would call G. So not only are we supposed to graph G on the Cartesian coordinate plane, but we're also supposed to analyze G by identifying the following things: intervals of increasing and decreasing, the relative extrema, that would be the relative maximum, as well as the relative minimum, and the intercepts. So there's always the potential for 2 intercepts, the x-intercept and the y-intercept. So we'll want to do the analysis of G. Having the graph in front of us is really helpful. That's the way that we accomplished this in a prior section, I believe it was section 2, where we analyzed the graph of a function. So now you can produce the graph for yourself, and then you can do the analysis. So starting with increasing, decreasing. If I start at the top left and I move to the right, I would be decreasing the whole time. So there's only one interval of increase or decrease. So I would say that there is no increasing intervals. We'll say none. And then decreasing is going to be happening all the time. So over the entire domain of all real numbers, I would say that it's decreasing. Now, because it's decreasing the whole time, we're not going to see anything like this, where it goes up and then comes back down and then goes back up, because those are the kind of situations that would get us things like the relative maximum or a relative minimum. But since we don't have anything like that taking place, there are no relative maximums and no relative minimums. And you'll want to think about, is that going to be true for every linear function that I encounter? Will there ever be a maximum or a minimum in one of those? And then the last things we have are the x-intercept and the y-intercept. Now the y-intercept we get for free because we pulled that directly off of the equation. So the y-intercept is located at 0, 5. And you might be able to look at the graph and notice exactly where the x-intercept is. So I'm marking it here on the graph. It looks like it's about 2.5. But I don't want to be approximate. I want to know for sure where it is located. So I want to show you how to algebraically calculate the x-intercept, just in case you're not 100% sure graphically where it is. So for your x-intercept calculation, you need to let your function be equal to 0. So you're going to let your function notation, g of x, be equal to 0. And the reason why we do that is because that would be analogous to saying let the y value be equal to 0. So the y value is 0 all along the x-axis. So any point that's sitting on top of the x-axis has to have a y value of 0. So by forcing the equation to have a y value of 0, it will allow us to calculate the exact location of this x-intercept. So now we're going to say 0 is equal to negative 2x plus 5, and I'll add 2x to both sides to get 2x is equal to 5, and then divide both sides by 2, and I get x is equal to 5 halves, which is equivalent to 2.5. So we could have found this graphically just by looking at it, but I want to caution you on that because that will not always be the case for every linear function that you deal with. This algebraic approach will be very useful. So then we would write the ordered pair 5 halves, comma 0 as the location for the x-intercept. And this is all the information that I would box in. That's what I was supposed to be finding. And then of course the graph speaks for itself there.